So the other type of annuity, the ordinary annuity. Remember, the difference between the annuity due and the ordinary annuity is when the payment or the deposit is made. So it's now going to be made at the end of the compounding period instead of the start. Which means our future value will now be P plus PR squared and so on. It just changes the series a little bit. The first term now is P instead of PR, and the last term is PR to the n minus 1 instead of PR to the n. So that would become our future value. P is principal, R is the interest rate and so on. And similarly, our present value, we get a similar formula to what we saw before, but slightly different there. Loan repayments, that's basically what we're talking about here. Think of it this way. If you, at any point in time, you could say the amount that's still owing would be the principal plus the interest minus the instalments plus an interest. And why do we think of it this way? We think of it this way because we're actually looking at two types of investments. One is the bank investing in you, the other is you investing in the bank. And the difference between the two is how much money you still owe the bank. So Richard and Kathy are going to borrow $20,000 from the bank to go on a holiday. That's not a bad holiday, $20,000, okay. Interest is charged at 12%, compounded monthly. They start repaying the loan 1 month after taking out. They're going to pay back $300 a month. So after 6 years, how much will they still owe the bank? We have borrowed, or they have borrowed, for 72 months. So the bank has invested in them for 6 years, but we're talking months, so that's 72 months. So there's the bank's investment. Here's $20,000. I'm leaving it with you for 6 years. So the repayments, it's like an investment, but it's a reverse investment. Now, Rich and Kathy, they're going to invest in the bank. We're going to give you $300 every month. So that first investment's there for 71 months. Then the next one's there for 70 months. And so on and so on and so on. The second last one will just be there for 1 month. And then the final repayments, well, it's just, here you are, job's done, we're finished. So there's no interest on that. The amount owing after 6 years then is one minus the other. And there it is. The second one, there's our geometric series that we can use our formulas for. So if we sub in, and it's just a bit of calculator work now, but there it is, $9,529.01, and you bet your life they'll chase you for that 1 cent, is what we still owe, or they still owe the bank. So how much interest have they paid in those 6 years? Well, they've made 72 repayments of $300. So they've given the bank $21,600, but they borrowed $20,000, remember, and they still owe $9,529.01. So $20,000 is what they borrowed, $9,529 is what they still owe, so $10,470 is basically what they've reduced the loan by. So the interest would be how much we've paid back minus how much we've taken off the loan, because that gap then must be the extra money we've given the bank. So $11,129.01. Well, how about we change the question, and instead of it, we want to work out how much we have to pay. And you might want to do that, like if you go, well, I need to buy a car. So Yog's buying a car, it's worth $30,000. And he says, look, I've got 5 years, I'll give myself 5 years to pay this money back. I know the interest rate, so how much am I going to have to give them each month? So let that monthly instalment be M. That's what we're trying to work out. The initial loan will be borrowed for 60 months. So there's the investment the bank is making in Yog. His first investment will be in there for 59 months. The next one will be in there for 58, and so on and so on and so on, until the last one, thank you, job done, we're even. So let's subtract the two. There it is. Our second one is our series. It's M that we're trying to work out. But the additional piece of information we know is this amount 60. Because after amount 60, where are we? Whoop, there it is. After amount 60, it should be zero, because we've got nothing left. We've paid each other back, if you like. So let's now make M the subject of all this. Playing around with it. There we go. So M turns out to be $622.75 a month we'll pay back on this one. What about if it was the length of the loan? We know how much we can afford to pay back. We know how much we want to borrow, and we know the interest rate. So, okay, well, how long is this going to take me to pay it off? An HSC question. Wheelbarrow of Shire Council borrowed how many noughts are there? $3 million at the beginning of 2005. Interest rate 12%. Each year, interest is calculated on the balance, etc., etc. The debt's going to be paid back. They're just going to make one lump sum every year of $480,000, and they'll pay it back at the end of the first year. Simply said, show that. So show that amount to would be this. So after 2 years, the investment in the council is 3 million, 1.12 to the power of 2. Our first repayment will just be invested for 1 year, and then the last one is just 2 years. So principal plus interest minus instalments plus interest, and if we play around with it, we've pretty much got it, because they've written in scientific notation, but 3 million is 3 times 10 to the power of 6. And yes, we have a common factor here of 4.8 times 10 to the power of 5. So we've got the answer. Show that amount n is this expression. So now we're saying it's n years. We want to work out how long. So 3 million, 1.12 to the power of n. First investment will be there for n minus 1 years, and the next one n minus 2 years, and so on and so on. Same idea, we'll subtract the 2, and we have our geometric series in the second one. Sub in, we want to try and get their answer. Well, nicely, 0.12 goes into 480,000 and we get 4 million. So there is that common factor when we expand out and we can get close to what they want. Because look what happens, we get the 3 million minus the 4 million, so we've got minus 1 million. We therefore have a common factor of 1 million, which is 10 to the power of 6, and we get the expression that they wanted. In which year will they make this final repayment then? Alright, so when is amount n equal to 0 is basically what they're saying. Solving that, log both sides, there it is. That'll be the 13th repayment we'll do it, and that'll be at the end of 2017. Okay, I went a little bit more recent. Tina inherits $60,000, invested in an account, earning interest at 0.5% per month. Each month, immediately after the interest has been paid, Tina then withdraws $800. So, okay. The amount in the account immediately after the nth withdrawal can be determined using this recurrence relationship. So nicely they gave us the formula. We don't have to go and work it all out using our series and what have you. They've done it via a recurrence relation, which you'll recall is an alternative way of writing our series using recurrence. Use it to find the amount of money in the account immediately after the third withdrawal. So amount 3 will be amount 2 when we substitute in, but we don't know what that is. But amount 2 will be amount 1, put the formula again, but again we don't know what amount 1 is. So we use the formula again and we get amount 0, and we do know what amount 0 is, so eventually we can substitute into the whole thing. In this one, because there's only 3 terms here, I'm not going to use our formula for geometric series. I'm just going to go to my calculator and type those in. It's going to be quicker than using all that. 58,492.49. So calculate the amount of interest earned. Well, the interest would be, it's 58,492, but how much did we have? We had 3 times 800, but minus $6,000, right? So the balance, there's our balance. We withdrew $800 3 times, but then we also originally had 60,000 sitting in there as well. So all of that, whatever's left, that should be the interest that we earned. That's $892.49. How much money's in the account after the 94th withdrawal? Don't know why they picked 94. I mean, anyway. Okay, amount 94. Now I'm going to have to use my formula for this series here, and we get 187.85. Okay, once again, I haven't set a heck of a lot of questions on that one, but